Thank you for the introduction. All protocols accepted. I'm going to follow on from the rather excellent feature address that we got from Tony Gibbs, which is a good expression of the reality of hazards and of the historical records. What I wanted to talk to you a bit about is a little bit more queasy. This is projections. So this is not real. Okay? It's about climate change because you're looking at long-term trends. Okay? So if anybody tells you anything about predictions, they'll be wrong. That's a bad word. It's been used this morning already. Predicting. Whatever you predict, you'll always be wrong. You can project within a range based on the best available science. So with that proviso, I'm going to talk about climate change scenarios. I'll give you some idea into what is emerging out of the Intergovernmental Panel on Climate Change. One of the lead authors on the small islands part of this. So we looked at all the small island regions of the world and looked at what we might expect in the future and consequently, how we should be guided. So we'll start off by, let me just tell you something about the new climate projections. There's some old climate projections, the special report on emission scenarios is what it was called, SRES scenarios. These are now being replaced with new projections using the very latest emissions data. So the so-called representative concentration pathways are simply based on the physics. This has nothing to do with human negotiations about greenhouse gases or anything. Based on the amount of greenhouse gas emissions, one can calculate, due to their warming potential, how the atmosphere will be warmed, and consequently what temperatures, for example, are likely to result. So you'll see on one of the axes, the radiative forcing is the warming potential in watts per meter squared, okay? Based on concentration of greenhouse gases. This is pure physics. And along the x-axis, you'll see from the historical records of emissions, the 1800 up to, you'll see present, you'll see a shaded bar. So you'll see exactly where we are at the moment. You can see the line has departed. Okay, we're warming on a trend, but we don't know about the future. We don't know where we will go. So you'll see 4 projections. Now there are 48 global modeling groups all around the world, and they have run various scenarios, and they've chosen one scenario to represent the mid projection of each group of scenarios. The bottom projection is that if next year, when there is a meeting, the Kyoto Protocol expires, and we are surprised that all the countries come to an agreement to limit greenhouse gas emissions and it's enforced, then the atmosphere will stabilize and eventually will decrease. Not going to happen. Okay? Most recent meeting was in Poland. You might have read about it in the papers. And they agreed finally on a text in which each country was asked to make contributions, not commitments. And the contribution word strangely came from Trinidad. Nobody wants to make a commitment to reduce to any amount. We'll see what we could do. Contribution. And when they couldn't agree on the last day, it went into an extra day, and they took Trinidad and Tobago's word and introduced that in the text, and everybody agreed to sign that they will look to see what contributions they could make. Okay? So Trinidad, or Trinidad as they call it, has contributed something globally. So you'll see the trend is going up. And if an agreement is arrived at, it might stabilize, but I don't think it's going to happen. I think what is likely to happen in the future is one of the trends going up. Okay? So I think probably the mid one, what is called RCP 6.0. So let me just go. So the highest projections are if the carbon dioxide equivalence comes up to 1350 parts per million, okay, then we'll get 8.5 watts per meter squared of warming, and the line is going to go straight up like that. If it goes up to 850 parts per million, we'll get 6 6.0 watts per meter. That's RCP 6.0 as it's called. If the concentration is 650, all right, now where are we at the moment? Okay, we're about 600. So if you go on the web, you'll see it's being measured every day, global average concentration. We're at 600 parts per million now. Okay, so if we come to some kind of imperfect agreement and we stabilize it to some extent and it only goes up to 650, this is what will happen. And if we are, incredible, and we all come to an agreement in which we agree to reduce to our 1990 levels and is enforced, it will stabilize and it's going to go down. Okay? That's the warming will be 2.6 watts per meter squared. But I think the last one, now really on. Too late. We've argued for years and years. Nobody wants to make commitments. They're using Trinidad and Tobago's approach. Contributions. Now, so what I want to talk about is what the best science shows might happen in the future. I'm not predicting, projecting. So it's within a range depending on the human decisions that are made. We did some modeling. This is based on the average of the 48 global GCMs, as they call, global climate models. This is for the Caribbean as a whole. If we draw a box around the Caribbean islands and take that out, what are the trends? So to the left, you'll see the temperature. You'll see the line with those four scenarios. You'll see the range. This is all the models imposed. You'll see the trend quite clearly is going up. And you can see on the right-hand axis, you'll see the temperature, that the temperature range is likely to be probably, if it's in mid-range, probably an increase of 2 degrees centigrade by the year 2100. If on the right-hand side you see projected precipitation, and this is the annual average, okay? Not much difference in overall precipitation, okay? Except you might see the red line appear down below if we go to the highest scenario. But if we look at the wet season, on the other hand, you see the temperature change during the wet season, those months. You see the temperature change is a far greater range. And if you look at the precipitation change, which is what I'm mainly interested in, you'll see that it anticipates, you can see a quite pronounced trend of two things. One is, in the future, going forward, you see the line is going down. Reduced precipitation, okay, during the wet season. And if you look at the spread, you'll see the spread seems to be outside of the historical records. That is, an increased frequency of extreme events. Long range, short period of time. Have you seen it happening already? I wouldn't say it's happening already. I'm talking about long-term trends. But some people think, gosh, we had it happen down the islands just recently. Incredible amount of rain in a short period of time. Okay? So it's some places are Australia hot, other places freezing. The climate is going between extremes. Okay? Rainfall, not in a short period of time. And then extreme dry periods. So the climate machine is varying out of bounds. Okay? And you can see in all of the global models superimposed, you see the wider range. Okay? Alright. So there are implications for engineering, of course. I think the feature address was perfect. Tony Gibbs said it all. Okay? What the impact of this, and I haven't spoken about the wind speed yet. See, the projected impact of all of this has a vastly different effect depending on whether you take measures, okay, adaptive measures. So one of the problems we have, let's say take Trinidad and Tobago, is when we downscale global models, if you don't have enough historical data, you can't really downscale very, very well scientifically. So if you downscale to 25 kilometers squared, these are 12 boxes, 3, 6, 9, 12 boxes on Trinidad. You'll only be able to get local projections within a 25 kilometer squared box in Trinidad and Tobago, including the topography and so on. So it's a challenge because in most islands we don't have enough historical data to calibrate the models. But in some places, there's more than the airport. In Trinidad, the only official WNO station is Piarco Airport. Okay? And although Trinidad claims to have several weather stations, no data is provided from Trinidad other than for Piarco Airport and Crown Point in Tobago. Okay? But we supposedly have had for generations several stations. All right. Now, I want to just make one point, and I think Tony Gibbs made this point as well, that there are two aspects of what the impact is. One is, this is just a theoretical diagram. One is the climate signal. So along the y-axis, climate signal, and along the x-axis, what happens is dependent on, I think it's variant with socioeconomic development. That is, I'll take Haiti as a good example. There was a 7.0 earthquake in Haiti 4.5 years ago, and everything was destroyed because they didn't enforce any building codes. There was a 7.0 earthquake in Chile that year, and the consequences were completely different. The physical signal is the same, but there they enforced the building codes. Okay? So the level of damage was completely different. So it's not merely the physical signal, whether it's earthquakes, hydrometeorology, winds, and so on. The engineering is critical. If you do not engineer to meet those requirements, then the damage impact is a lot greater. Okay? So we can't just talk about increasing temperature, rainfall, etc. That's physical signal. Right. I missed over something. All right. Right. So let me just go to quickly and end in 2 minutes. The issue of the fact that Trinidad is supposedly outside of the hurricane belt, and we are certain, for those from Trinidad and Tobago, that God is a Trini. I want to suggest to you that luck is about to run out. I think there are some trends. Some work we are doing now, we hope to publish something, looked at the genesis of tropical storms. All those dots are genesis of tropical storms during a particular period of the year, and linked to sea surface temperature. This has been the long-term trend, those bands. But all I want to show you is that if you look at the line, the blue line across, you'll see that previously at the top diagram, there were no tropical storms other than the hurricane that was mentioned many years ago down by Brazil. There were no tropical storms in which the genesis was below the latitude of Trinidad. If you draw a line through the end of Trinidad, through Baruga, Cedros down there, hurricanes form off of West Africa, they move across the Atlantic, and we throw a fet because we know it's going to turn. It's going to hit the islands, and nothing will happen to Trinidad and Tobago. Okay? So no tropical storms were generated below the latitude of Trinidad. But in the last 10 years, if you look at the second diagram down, you'll see that there have been 8 that have passed that line for the first time. So this is what you would expect with global warming, that hurricanes will start to form closer to the equator, which is warming up faster. So that if the genesis of storms shifts closer to the equator, when the turn play comes, we might be right in the way. Okay? Luck. We're looking at a trend. Luck may be running out. Engineer for the future. Point was made in the earlier discussion as well. All right? Engineering has got to take these trends into consideration. If you engineer for today, that is based on your expectation that the conditions will remain the same. But if the conditions change, the baseline change, that also has to be factored in. And all the evidence seems to suggest there's something for us to look at. Okay? So all of this is being put into models and so on to look in Trinidad at potential impacts on coastal flooding, storm surge, and so forth along the coast, on rainfall, and what infrastructures on the coast, and physical characteristics. So coastal flooding, wind, rainfall. Just showing you some diagrams of work that's ongoing in Trinidad and Tobago. Right? And so this is my last slide, and that will be put together. Those projections will be put together with hazard maps that should inform the engineering. Okay? So thanks very much. I hope that stimulates your thinking about what I think needs to happen next. Thanks for your attention.